Alright, today we're going to talk about solving polynomials of the third degree. It's the objective to solve or find the roots and zeros of a third degree polynomial by factoring or using quadratic formula, and we'll throw in some long division as well. So the main thing we're focusing on today is only the third degree. And of course that'll break down into a quadratic, and we'll have to solve that as well. But we're not getting over anything bigger than the third degree. So no x to the fourth, fifth, nothing like that. So we're just focusing on the third degree polynomials. When I talk about roots and zeros, it basically, those are the same thing as saying solving for x. I'm looking at basically taking the polynomial and setting it equal to 0. So basically plugging 0 in for y and solving. That is solving for a root or a 0. Alright, so here we go. So the first one, we're going to solve the polynomial 6x to the third power minus 3x squared minus 45x. Now, to solve this, the first thing we want to do is look to see if we can pull any factors out, greatest common factors. So the first thing I notice is 6, 3, and 45. I can pull a 3 out of each of those, and then x to the third, x squared, and x. I can actually pull an x out as well. So I'm going to go ahead and pull a GCF out. And when I pull that GCF out, I'm not just pulling an x out, I'm also pulling a 3 out. So I'm going to pull a 3x out. I'm going to factor that out. And when I factor that out, I end up with 3x times 2x squared minus x minus 15. And that, of course, still equals 0. That equaling 0 is just kind of going along for the ride for right now. But it's very important to have it equal to 0. Don't think that that is by mistake. All right, so now I've pulled out my GCF, my 3x. And what I have left in that parenthesis is a quadratic, 2x squared minus x minus 15. And now I can go ahead and take that and break that into two parentheses. So I can factor that. And when I go ahead and do that, I'm left with 3x times 2x plus 5 times x minus 3. Now, with factoring out the GCF and factoring the quadratic, if you need any help on that, go ahead and in the upper right hand corner, click on the link there, and it'll help you with factoring a GCF out, and it'll help you factor the quadratic. Both of these are things that I'm assuming that you already know how to do, but in some cases just a little refresher might help. Alright, so let's continue here, but definitely if you need to, review that material before we move on. Alright, so at this point we have the factors 3x, a factor of 2x plus 5, and a factor of x minus 3. And they're factors because if I multiply all these back together, I still get the original polynomial of 6x to the third minus 3x squared minus 45x. Alright, so now I'm going to go ahead and look at the solutions of x. And the solutions are all, I have 3 of them. And how I know I have 3 of them right from the get-go, well, really before I even started the problem, to be honest, I knew I had 3 of them because I have an x to the third power. And that power tells you how many roots or solutions, or I guess I could call them instead of roots, zeros, that I have. So if I have an x to the third, I have 3 solutions, 3 possible solutions. If I have an x to the fourth, x to the fifth, so x to the fifth, I would have 5 solutions. X to the fourth, I would have 4 solutions. So in this case, I have an x to the third, so I have 3 solutions. And where those 3 solutions come from are the factors. I have 3 factors. So I can go ahead and look at these and come up with my solutions. And those solutions is this: x equals 0, 3, and negative 2.5. Now, how in the world did I come up with those? Well, what I did was basically looked at how can I make I'll look at x minus 3 first. How can I make x minus 3 equal 0? Because think about it. If x minus 3 equals 0, 0 times the rest of it goes to 0. Because think about, what is 2 times 0? 0. 5 times 0? 0. What's 2 times 5 times 0? Or 10 times 11 times 15 times 0. Anything times 0 is 0. Therefore, when you're looking at 3x times 2x plus 5 times x minus 3, I'm looking at each individual parenthesis and setting that equal to 0. So I took 3x, because when I say each parenthesis 3x, I could put parentheses around. It's not, but in my head, that's what I'm imagining. There's nothing illegal saying I can't put 3x in parentheses. But what I'm looking at is each parenthesis, if I could talk, and I'm setting it equal to 0 because I'm taking 3x equals 0 and I'm solving for x. What do I get? 0. Then I take 2x plus 5. I set that equal to 0. So I'm taking what this parenthesis is and setting it equal to 0 and solving. When I take 2x plus 5, set equal to 0, and solve for x, I get negative 2.5. Because you subtract the 5, divide by 2, you have negative 5 over 2, which of course is negative 2.5, negative 2.5. And then x minus 3. Solve for x, you add 3 to each side, x equals 3. So your solutions, okay, in this case is x equals 0, 3, and negative 2.5. So these right here are your solutions. These right here are your factors. And I basically use my factors to get my solutions. Now, for each of these solutions, 0, 3, and negative 2.5, I can take those and plug them in for x up here, and it will get a solution of 0 when I simplify it. So think about if I take x equals 0, to start with that top solution, and I plug it in for everywhere I see an x in the original 6x to the third minus 3x squared minus 45x. Well, if I plug in 0, I end up with 0 to the third times 0, 0 squared times 3 is 0. So I have 0 minus 0 minus 45 times 0 is 0. So I have 0 minus 0 minus 0. Well, of course that equals 0. Okay, good. But then try 3. Plug 3 in. You will get 0. And if you want, you can pause and test that out and test out negative 2.5. I'm not going to. But you can absolutely do that. So if I take each of those solutions and I plug them in, bam, I simplify the polynomial and I get 0. And you should, because where'd you get those solutions? From the factors. And where'd you get the factors? From the original polynomial. So basically, a recap here. I take the polynomial, I factor everything out that I possibly can, and after I have it factored down to the simplest form I possibly can get, I take each of those factors, I set equal to 0, and I get my solutions of 0, 3, and negative 2.5. Alright, so now let's look at a more difficult problem where we actually have to use a quadratic formula and long